Following the introduction of modifications which had been indicated by the results of full-scale tunnel testing of the Avrocar at NASA Ames Research Center, a continuation test program was begun. The objective of this program was to prove the effectiveness of the new control system from hovering through transition in the presence of the ground up to free flight conditions. The program consisted in the main of further wind tunnel tests at Ames Research Center to prove the effects of these modifications, with a short flight test program at Avro to establish that the hovering capability had not deteriorated. A brief terrain test program was later added. The modifications provided for aft deployment of the peripheral jet sheet from the wing tip for transition and forward flight. Both vehicles were modified, one for further static and flight testing at the Avro facility, and the other for tests in the 40 by 80-foot tunnel at Ames Research Center. The changes were confined mostly to the wingtip, which was modified to divert the annular jet aft for increased forward thrust and improved aerodynamic and control characteristics. Transition doors, which extend around the sides and rear of the vehicle, act as flow splitters to divert the flow gradually from the annular hovering nozzle to the new wingtip nozzle for transition to forward flight. With the transition doors in the forward flight position, wingtip cascades at each side of the vehicle direct the jet flow aft. Pitch and roll control in forward flight is provided by the addition of 6 control vanes which operate in conjunction with the existing focusing control ring. On completion of the modification program, the vehicle was installed in the static test rig for functional checking of the new control system and to determine as far as possible that the vehicle performance in the ground cushion had not deteriorated as a result of the modifications. Lift, propulsive thrust, and rolling and pitching moments were measured during the 4-hour static test program. For rig testing, the control system was actuated by an external hydraulic system to be sure of maximum control movement. Tufting was used to provide a visual indication of control vane operation and jet flow. On completion of rig testing, the hovering behavior of the aircraft was checked in the tethers before commencing free flight. It should be understood that the original objective of the flight testing in this program was simply to determine that installation of the modifications had not resulted in deterioration of the vehicle performance achieved during previous tests. Early flights revealed that some deterioration in stability and control had in fact resulted from introduction of the modifications, and a number of flights were required to restore the vehicle performance in this respect. During this 6-hour flight test program, various minor experimental modifications were therefore made to the hovering control system and to the central jet configuration. The forward speed of the Avrocar, with the transition doors closed, was found to equal the speed previously achieved. Operation of the transition doors was attempted, but it was determined that the pneumatic boost available for the control system was not sufficient to overcome the large asymmetric load on the focusing control ring. A more powerful control actuation system is planned for future development. In its current configuration, the Avrocar was operating successfully in the ground cushion at a height of 3 feet and speeds up to 30 knots. Preliminary results from the new series of tests at Ames Research Center were also satisfactory. It was now desirable to extend the Avrocar's operation, and the program was extended to include flights over various types of unprepared terrain and natural obstacles. Initial tests over gravel and small surface irregularities presented no problems. We were now confident of the vehicle's ability to negotiate appreciable obstacles, and a rugged course, partially gravel and partially grass, with a 3-foot deep ditch, was selected for the next flights. Again, the Avrocar covered the course successfully, becoming, as far as we know, the first ground effect machine to negotiate obstacles of this nature. The vehicle had now clearly demonstrated its ability to operate over unprepared terrain, and landing pads were installed in place of the wheels for the following phase of testing, which included operation over soft ground. A number of flights were made over this course, which had a rough, eroded grass surface and a short 1-in-8 gradient. During most of these early tests, ingestion of low-density material presented some difficulty. The fuel control unit filters became blocked with small particles, causing the engines to be starved and resulting in flights of short duration. The problem was caused largely by dead grass and weeds.